Okay, so today my video is going to be on inverse trigonometric functions, or 5.6. And before we start, let's go ahead and define inverses as they pertain to trigonometric functions. So, if function f has a coordinate point AB, then the inverse function f negative 1, it should say there, has a point BA on its own graph or coordinate plane. And inverses only exist for trig functions when their domain is restricted. Functions must be one-to-one and monotonic. So let's go ahead and look at arcsine here. This is the graph of arcsine, and if you turn it sideways, you can kind of see that it looks like our normal sine graph, but the graph is flipped, as we said in our definition. AB is now BA, and our domain here is restricted. In order to make it one-to-one or monotonic, meaning we don't have it going up and down or oscillating as it normally does, which would mean we could cross it in a vertical line test and it would not be one-to-one. So now that our domain is restricted, -1 less than or equal to x less than or equal to 1, and our range is -π/2 less than or equal to y, which is less than or equal to π/2. So all of the graphs of each trig function has its own restricted domain and range in order to make it monotonic, and therefore there can be an inverse. So let's go ahead and look over here. Here are all of the graphs of each inverse trig function, and as you can see, all of them are monotonic and their domains and ranges are restricted. Now for cotangent and tangent, their domains are restricted, but their ranges are, so it makes them both monotonic. Alright, so let's go back over here. Alright, now let's look at evaluating inverse trig functions. Now let's evaluate cosine of the inverse tangent of x. Now when we read this, and this helps me a lot, we should read it as, what is the cosine of the angle whose tangent is x? So whenever we see an inverse, we think, what is the tangent of it? What angle has a tangent of x? That's how we should read that. So in evaluating this, we first need to know that tangent is equal to opposite over adjacent. In our little triangle here, opposite over adjacent. And since they gave us x, this means that opposite over adjacent is equal to x over 1. So we can go ahead and make a triangle. This is a really useful trick. So here's theta, opposite, which is our y, over our x and our r, just as Pythagorean theorem shows us. Alright, so now we got our triangle made, and we know that x squared, the square root of x squared plus 1 squared will be our r, just by Pythagorean theorem. Alright, so we've got our first step. So it's wanting the cosine of this triangle. Well, we know cosine to be adjacent over hypotenuse. Alright. So we want adjacent over hypotenuse. So here's our adjacent here, which is 1. And our hypotenuse was the square root of x squared plus 1. So that's all we have to do. So we have our adjacent and our hypotenuse. And that's how we would evaluate that. Now, we don't really have to memorize these because we should have prior knowledge, but it helps to know that sine of u is x over r and cosine of u is r over x, because you're going to have different combinations. This could be tangent of the inverse cosine of x. You know, it could be either way. Alright, so that's a portion of what we need to know on inverse trig functions.